All right, so the last piece of notes for this section on DNA is mutations. There's two mutations that we need to talk about, and then there's a word, mutagen, that we need to talk about. All right, so the two types of mutations that typically occur, one is called the point mutation, which you see highlighted here. And what happens in a point mutation is one single amino acid is swapped out or substituted with another amino acid. So if you look at my original strand here, you can see there's a C that's supposed to be in this nucleotide sequence. If you look in the mutation, with a point mutation, you can see that my C was taken out and a U was replaced in there. So you think, well, what's the big deal about that? Well, the A being in there in that sequence, then you've got, this is your first codon, right? GAT is your first codon. Your second codon is going to be CTA, where it was over here CTC. So CTC coded for the amino acid glutamine, and over here it's coding, the CTA codes for aspartic acid. So you can definitely see that that's a problem. So then the rest of the nucleotide or the protein chain is going to be fine, but that one protein is going to be out of place, which may have little to no effect, or it may have greater impact. Of the two types of mutations, however, point mutation is the one that is typically less catastrophic, if you will. All right, moving on. There's my bunch remover. All right, so then the next type of mutation is called the frameshift mutation, and in this case, a nucleotide is either inserted into the sequence or it's deleted completely from the sequence, and yeah, it's going to definitely change the amino acid that it codes for. So here's my normal strand, and you can see that it's GAT, CTA, AGG. Okay, so this is the one that we're working on. Well, what happened is the G, one of the G's, has been deleted from the sequence. So if you count your base pairing here and down here, you can see big change. So first three new codon, next codon, the codon AGG gives you serine. Okay? If I do my coding here, everything's shifted. So GAT's first codon, CTC is the second codon. Now AGC is the third codon, and that gives me the amino acid serine. And then it changes everything in the strand from then on because they all got displaced. It's kind of like, and if you look at your vocabulary pictures, if you think of it in terms of a sentence, if this was a sentence and it read, the fat cat sat on the mat, right? All three-letter words that make up a sentence. However, if I took out the C in cat and I moved all the letters so I always had three-letter segments, the sentence becomes completely unreadable. None of it will make sense anymore. So anyway, that's what happens with frameshift. Now you've got this huge change to the DNA sequence, definitely changing what protein is produced. Last thing you need to talk about is mutagens, one of your vocabulary words. A mutagen is just any substance that can cause a mutation. Chemicals, so it could be something you drink or something that you breathe in, those type of chemicals. Sunlight would definitely fall into the category of causing mutations. You know, it leads to skin cancer. Cigarette smoke, alcohol, drugs, anything that you're going to put in your body that's going to potentially cause a mutation would be considered a mutagen. But the unfortunate side is if it's in the air, if it's in all the potentially in the air that we breathe and the water that we drink, you know, how do we really keep ourselves safe? And that's where a lot of environmentalists are really being very active about keeping track of air pollution and water pollution, so that we don't have those issues with the air and the water we drink. Air we breathe and water we drink. All right, so that's it, guys. Those are the only notes on mutations. I promised you short and sweet after that big long one on transcription and translation. So I will see you in class on Monday for a quick little 5-question quiz. Have a nice weekend. Enjoy.